So those of you that subscribe to the channel will know I'm really interested in solar right now, and I'm actually supposed to be getting solar installed at the house next week. But what I thought I would do is give you guys an overview of what's involved in designing a solar PV system, and I thought it might be of interest. So I'll start off by saying I'm not a qualified solar PV designer or anything like that, so this is really just more about me sharing some of the research I've done specifically around the SolarEdge system, because that's what it is I'm having my installation based around. I have access to the SolarEdge design platform, so I just thought I'd share that with you so you guys can kind of see how you map things out, how you work out how much power you can potentially generate, what clipping you might have, that sort of thing. So hopefully this is interesting, and let's kind of connect in to the SolarEdge tool and see what it's all about. Okay, so I switched over to audio on my Mac, and hopefully that's okay. So let me take you through kind of how this works. So we're in the SolarEdge site designer, and like many companies, they're utilizing the benefits of Google Maps or Google Earth to understand kind of what kind of sun penetration and stuff, I guess you get, or daylight penetration, how things work there, and also then to utilize the roof layout to go from a 2D to a 3D kind of transformation. So let's get to it. So we'll start off with a new project, and obviously as we go through this I will blur out a couple of things just to keep things easy. So let's do a quick demo install. So for here, ask you for your coordinates, so you can put in any postcode or latitude and longitude, and it will take you into that area, and it will also look for the closest weather station to that area, which is going to obviously help understand historically what the weather's like over time, so it can do the relevant projections. Okay, as we scroll down, it talks about whether else it's a residential or commercial property. We'll leave that as residential. You can put in consumption and all this sort of stuff here. I'm not interested in that right now. But what we will do is select the electric grid. So this is basically based on the area of information it knows about, what it deems to be available. I'll just change it down to 230 so that we know that's all good. And we won't bother with the export limits, but in the videos you've seen before, you'll know by basic kind of approvals you can have like 3.68 kilowatt export. If you're going to have more than that, then you need to get your DNO approval, and obviously I've gone through that process to have 6 kilowatts. But this gives you some insight. So then it takes you over into the site modeling area. So this is obviously where it thinks you are. So if I zoom in to where I am, you can see how this works. So one of the things about the setup that I'm going to be doing here to mimic kind of the install I'm having is I'm doing this across 2 roofs. I'm having it across the house roof and of the roof of the cave. So that does complicate things a little bit in terms of how this modeling software works. It does work fine for that. It's obviously just a little bit more complicated. So if you're just doing a single roof, which I guess is more common, then things are a little bit easier. So one of the things that I can't do with this tool in terms of mapping it out is just limit or I guess connect these 2 roofs on a singular string. And I talk a little bit more of that as we go through, so kind of keep that in mind, but the total outcome should be similar. So first thing that we want to do, let's get rid of this stuff here, is map out the roof points. So obviously we do this the best we can based on the imagery that we have. So we start off here, go across to there, and across the back here. So where possible, you want to try and use how it snaps to, but at the same time you don't want to lose the right coverage. So to there and to there. So that's one done. And we also want to put a line across for the top of the roof. So this is also a bit difficult because of the camera angle, but we have to work with what we can work with. Oh, don't want that. So you can see here is about the top of the roof, and we're going to go across here. Again, like I say, this isn't ideal, it's not perfect, but it's going to give you a rough idea. And basically, the way this software works is it's taking obviously the full size of the roof, and then we're going to adjust this later based on the pitch of the roof, and that will kind of try and calculate the surface area that we have for the panels. So let's do the other roof as well. Out there, there, back there, over here, and the centre of the roof is about there. Cool. Okay, so once that's done, we can then flip to the 3D model, and this is what then allows us to adjust the pitch of the roof. So we just click in one of the areas here and on the line, and you'll see right here it's got the tilt. So we just click and drag that up. So I have a 40-degree pitch on my roof. So there we go. Do the same for this one. Okay, and so that's basically working out roughly how much roof space we have for the panels to be able to work with that. So that's the site modeled. So this is kind of the area that we're working with. Now what we need to do is basically define the equipment that we're going to select. So if we click on the roof, it zooms us in, and we click on this little button here for add PV modules. So again, we'll work this off my system. So as you can see in here, the majority of the most common solar panel manufacturers are in here. So they have all the statistics, the sizing, everything. I'm having the Pymar panels installed, and I'm getting the SG300Ms. So as you see in here, it has all the information about the panel, so you can confirm that what you're installing is right, and it's obviously got the dimensions and everything. So it's really handy. It takes a lot of the effort out of it for you. Now, a conventional house like mine is flush mounted. If you had a flat roof, you might have a tilted installation, but I don't, so we'll leave that as this. Then the azimuth and the tilt has been calculated already based on that previous site modeling we did. So then we have a few other options. So you're going to decide if you're doing portrait or landscape mounting of the panels, and then if you have any specific requirement for certain spacing in the columns or the rows. So for this roof, we're going to leave it as portrait, and so if we apply that now, then we have this ability to kind of drag in this space and draw a big box, and what we see is the panels start to get populated on there. So as you can see, it kind of gives you an indication again, this rough mock-up is not that great because of how I've done the lines there. It gives you a rough idea of how many panels you could potentially get on that roof. Now, the other thing that you could do back in the site modelling stage, just to make sure that that's clear, if you go back to the 2D model, this little option here for obstacles. So if I was doing the front roof, which I'm not, I have a little peaked area here. So what I would do is I draw out the obstacle to cover that peaked roof, or perhaps if you have a chimney, so the chimney sticks out around here, or you've got skylights or something, you would basically draw those obstacles on there, and that means obviously when it does the space calculation, it knows that it can't do anything with that. So just good to keep that in mind. Let me see if I can make that line work a bit better actually, because it's a bit crap. Right. Okie dokie. So let's go back into the solar PV placement. So as mentioned before, we can add our PV modules. The information is already in here from earlier. So you just draw a box. Draw a box over the area and it will start populating with how many panels you can have, which is fantastic. So I know, based on what I think my design needs to be, because of how much roof space I have on the cave, I think I need to be able to get 22 panels on this roof, like that. Okay, so if we zoom out a little bit, so in total I'm going to have 30 panels. So again, this time we will change this to landscape. And so we want to be able to get 8 panels on here. So again, let's move this over a little bit. There you go. So there's the 8 panels. So altogether, that's 30 300 kilowatt panels, watt panels, giving us a total of 9 kilowatts of power, and it's estimating an 8 megawatt hour annual generation. So this is what we're dealing with. So it all looks kind of as we expect. So it'd be interesting to see what the actual design is, because I still have never seen that for what the panel layout's going to be, based on the measurements they did. But 30 panels is what we're looking for. So then we move on to our electrical design. So one of the things that's good about the SolarEdge stuff is a couple of things. One is the ability to oversize the system, but it's quite a compact system. So I select here the inverter I'm having, which is a SolarEdge 600 HT wave. Okay, so that's all good. Then I'm only having one inverter, so it's selected 2 there because obviously I've got 2 buildings, so it's kind of thinks I'm doing 2 at once, but I'm not. Oversizing of 150%, which is what we know about that. So the HT Wave SE6000 can handle oversizing up to 150%, so that's not a problem. I'm having the P300 optimizers. So if we do generate, we'll start to pull this stuff together. So one of the things that you'll notice is that basically you have to have a certain number of panels in a string. So you have to have at least 8. So as I start to do this now, you'll see it stays red, and eventually it will go green, because there's a minimum and maximum amount of power per string. And so in this scenario, 8 creates the minimum viable amount of power in the string. And I think from my calculations, it's, with the 300 watt panels, it's around 18-ish panels maximum that you can have in a string, I believe. So as I said earlier in the video, ideally I would increase this string a little bit to incorporate a couple of these panels in that string. Now the reason for this is in the connection to the inverter, I believe that by default there is only 2 connection points for 2 strings. Now that doesn't mean that you can only have 2 strings, but if you're going to have more than that, you have to have a string combiner, and that string combiner basically takes all those strings down into 2, so it connects directly in to the inverter. That's my understanding anyway. As mentioned before, I'm just interested in this sort of stuff, which is why I'm talking to you about it now. So now if we move on to the other roof, as you see, if I try and do all of them, it won't let me. See, we get to a point now where we've exceeded the string length based on the power. So what we'll do is we're just kind of keep this to 11, and then have another string of 11 here. And this is really cool actually. When they do the install, there's little QR codes on the back of each of the optimizers, and they can basically take these little stickers off with those QR codes and put them on like a paper map that they then can easily just scan in to give you what should be at the end of the installation an equivalent active version of this map. So there's a monitoring feature in the SolarEdge software that will basically tell me how each of these panels and the optimizers are performing. So it's really good to identify faults and quick remedy, that kind of thing. So really, really good. So as we can see now, we've basically got these 3 strings, 1 string here, 1 string here, 1 string there. So 3 strings all together. So now it's basically got enough information to kind of give us a summary of how much power we're going to generate. I wish that there was options for batteries and stuff like that, but there isn't right now. Maybe that will change in the future, but it's all good. So if we go to summary and reports, it basically takes that information that we have and produces a report. So as expected, there is 9 kilowatt total array altogether. The maximum it believes it will achieve, because obviously there's some wastage in terms of cabling and all that sort of thing, but it reckons it would maximum generation would be 8.46 kilowatts. It's oversizing that 6 kilowatt inverter by 150%, which is fine, completely within the parameters of the inverter. The maximum amount of power that inverter can go from DC to AC is 6 kilowatts, and it's estimating an annual energy generation of around 7.92 megawatts. So then when we look down here, we see a bit more about that estimated monthly energy. So this is where it's using a combination of the panels that we selected in the inverter and also that historical data from the nearest weather station. So it's basically looking at, in the past, kind of what has been the solar generation across these months, and then trying to estimate what your potential generation may be. Now, as you'll see here, there's obviously a level of clipping. So what that means is basically during the months April, May, June and July, August and a little bit of September, there's going to be more ability to generate solar power than I can convert into exportable energy due to, I guess, that bottleneck of the 6 kilowatt inverter. But you can see that, I mean, that's minimal. So I could obviously spend money on to have another inverter and have increased approval from the grid to pump more in. But I just don't think it's worth it, right? Because you can see I'll be spending all that money for a 1.38% increase. So this is where this tool is really helpful for you to understand, the generation and what's going to be clipping. So it gives you a little bit of information here on where some of the losses are happening. So some element of reflection loss, that's going to be due to the angle and the pitch and everything. I'm not quite sure about irradiance. I think that's something to do with the heat stuff. The temperature loss, this is something that I think lots of people don't realise. The panels obviously have an optimal temperature, and especially in that extreme heat for UK that we've been having recently, that impacts the panel's ability to generate electricity. So all these things are factored in. Obviously then you've got the DC to AC conversion, which eats into it a little bit, and then obviously the clipping over time, which is basically what's bringing me to that 7.92 megawatt hours per year. Now, that's slightly less than I was quoted by the installers, so that's why it'd be interesting to see what's more accurate, the install proposal or kind of my design here. Like I say, the actual layout of the panels shouldn't make too much difference, but saying that, I don't really suffer from shading, but obviously if they put more panels in one area than the other, and if there is some shading, that will have some impact, but that's basically where it is. So it basically gives you some information, clarification on what it is, obviously, that you're purchasing, what the electrical design is, what things that you need to purchase, and then basically you could export this into the monitoring system. So that then when you do come to do the install, the monitoring system already has a layout of what it's expecting. Okay, so I hope that was helpful. Just give you some insight. So if you do obviously decide to get solar, this is the kind of tooling that the solar designer is going to be using to try and map out what system makes most sense to you. Obviously they'll probably have their preference on the types of panels and everything that they're using, and they can kind of model these things in a tool like that. Obviously this is specific to SolarEdge, but I know other companies provide similar tooling, so it's all kind of like to like. It's not supposed to be freely available for the consumer or anything. This really is for the design team to try and map this stuff out, but hopefully that gives you some insight into what's happening in the background, and perhaps this is a discussion you have with your installer to show you some of this stuff, right? So how did they come up with the design? And they will generally give you copies of those reports. So they will use that tool to generate a report when they come back to you and say, hey, look, we're going to quote you this much money for the system. This is what it should generate over the year. And then they will have their own calculation model based on what you've told them your electricity costs are and what tariffs you're on, and then what the payback time should be. So that's it. We'll see what happens with the install over time, and I must make a note, I guess, to do a video a year on from now to see what the results were versus what we proposed it would be with these calculations. Thanks for watching this video. A thumbs up would be really appreciated. If you're interested in other geek type videos, please consider subscribing to Spectrum Geeks. Why not also follow us on Facebook, Instagram and Twitter. And before you leave, why don't you check out one of these other videos that may be of interest. Thanks again for watching.